Good afternoon. Today we're going to work on finding the area of regular quadrilaterals. A quick review, a quadrilateral is a four-sided polygon, and a regular polygon is a shape in which all sides are equal and all angles are equal. To review our vocabulary, we recognize this as being a four-sided figure with equal angles and equal sides. We call these squares. Our square has a side. Our square, as we learned with the triangles last lesson, also has a center. Our square has a radius. The radius goes from the center to any of the vertices and has the special property of bisecting the actual angle. If all my angles are equal, then that makes, and we know one property of a square is that all the angles are 90 degrees, then my radius bisects that angle and creates a 45-degree special triangle inside. Additionally, we know that our polygons have an apothem. And the apothem is a segment that goes from the center to the midpoint of any side at its perpendicular, splitting the side into two equal pieces. By doing so, we create a special 45-45 right triangle embedded inside our square. We can use the formula area equals 1/2 perimeter times apothem, but we can also use the more traditional area equals side squared formula if we prefer. I'm going to do example 1, showing you both ways to find that area, and then you would be able to choose the one that works best for you. In looking at example 1, I notice that the information I'm given is the length of the apothem. I'm going to go ahead and label that. That's going to help me because if I use my embedded 45-45 isosceles right triangle, then I can find the distance from the midpoint to the vertex. Let's do that very quickly. I like drawing my embedded triangles separately. I don't do them very well to scale, but I think back and I remember that in a 45-45-90 right triangle, the sides are congruent and the hypotenuse is always the length of the side times the square root of 2. If I then label my special right triangle with the information I was given, I now can see that there is a relationship between the apothem and the distance from the midpoint to the vertex, making this also a 9-inch segment. I can then calculate the length of the entire side. It's going to be 2 of these, or 18 inches. To use the more traditional formula that you've seen since elementary school, I can take the area, find the area by taking the side of my square and squaring it. If I do this and substitute 18 in for the length of my side, then I learn that 18 squared is 324. I'm not going to forget my units. If I wanted to see what the answer would be using the newer formula, I can do this as well. To do so, I need to find what my perimeter is. So I'm just going to take a moment to calculate my perimeter. My quadrilateral has 4 sides. Each side is equal to 18, so the perimeter of my square is 72 inches. I now have enough information, because I was given the apothem, to calculate the area using this formula. I like rewriting the formula because then it just becomes a substitution exercise. I know my perimeter is 72. I know my apothem is 9, and I can throw all of this into a calculator. I can do some mental math, and the result is the same as when I calculated it using side squared. So the area of this particular square is 324 inches squared. I'm going to go ahead and skip to example 3 In example 2, we are given the same information as in example 1, so I leave that for you to use as a practice problem. In example 3, we are given different information. In this case, we are given the length of the radius. The radius is not helpful to me in either of the formulas, so I need to go back to my 45-45 right triangle to see if I can calculate what the length of the apothem is. And I know that the length of the apothem is the same as the length from the midpoint to the vertex, so that will help me. I'm going to label the relationship of the sides of my 45-45-90 right triangle, and I'm going to go ahead and label my picture with the information I was given. By doing so, I have an equation that I can use to find the value of x. I'm going to do that math over here. To find the length of my apothem, I need to isolate the variable x. I do so by dividing by the square root of 2. When I rationalize this denominator, I get 4 square root 2 divided by 2, and I can simplify that a little bit more and learn that the apothem, or the distance from the midpoint to the vertex, is 2 square root 2. I need to multiply that by 2 to find the length of the entire side, giving me 4 square root 2 as the length of my side. If I want to find the area using the old school side squared formula, I now have enough information to do so. I substitute in the length of each side, and now I square that. When squaring, I need to make sure that I remember to square both the whole number and the radical. 4 squared is 16, and square root of 2 times the square root of 2 is the whole number 2. When I simplify that one more time, I calculate the area of this particular square as being 32 inches squared. Don't forget your units. If you'd like to, you can verify this answer using the 1/2 perimeter times apothem formula, just for good measure.